Okay, welcome again to Manitofu Academy. In this session, we are going to see the probability for union and the intersection of events. Let us start with the intersection. The intersection of two events A and B, denoted by this symbol as you see, is the event that occurs if A and B are on a single performance of the experiment. What about union? The union of two events, A and B, denoted by this symbol, is the event that occurs if either A or B or both occur using performance of the experiment. Here we have an example to display the intersection and union concept. And we are going to associate union and intersection of events with the probability. Now let us see this example. It is stated that consider a die toss experiment to obtain the following events. The first event, which is event A, a toss, an even number shows up. The second event, which is event B, a toss, a number less than or equal to 3 shows up. Now we are asked to find the probability of A union B. Secondly, to find the probability of A intersection in B. Now let us see the solution for this problem. Solution. So the solution for this problem. Here, the sample space we have, after tossing a die, we get 6 possible numbers. As we know, a die has 6 sides, and these sides show the number 1, 2, 3, 4, 5, and 6. So our possible sample is number 1, 2, 3, 4, 5, and 6. These are possible numbers to be obtained when a die is tossed. Now, let us see the possible events. We have the first event, which is event A. Event A is to get even numbers. Even numbers here we have from this sample space. Even numbers here we have 2, 4, and 6. This is the first possible event. A second possible event, which is event B. Event B has a number less than or equal to 3. A number less than or equal to 3. Here, a number less than or equal to 3 is 1, 2, and 3. Is 1, 2, and 3. Now let us see A union B. A union B. A union B will be equal to A union B. When we have two sets or two events, as you see, and we are asked to find the union, we have to list all the elements from the two sets or two events without repetition. So here we are going to start. We have 1, 2, 3. 1, 2, 3. And which is not listed here is 4 from the first event. 4 and 6 and 6. So these are the elements of A union B. Now let us find number of A union B. Number of A union B will be equal to, how many are they? 1, 2, 3, 4, 5. They are 5. We have 5 elements. After A union B, let us find out A intersection B. A intersection B. A intersection B. A intersection B will be equal to A intersection B. Here we find the elements which are common to both two events or both two sets. Here the elements which are common to A and B, the elements which are common to A and B, as you see in A and B, we have 2. 2 has happened in or A and B. So A intersection B contains only one element, which is 2. Now the number of A intersection B, how many are they? It is only 1. So let us find the respective probabilities as asked. Part A, we are asked to find the probability of A union B. Now the probability of A union B will be equal to the number of events over number of sample space. So number of events we have 5 as the number of A union B are 5 over sample space. Sample space we have 6, so it is 5 over 6. Now the probability of A union B is 5 over 6. Let us see part B. Part B, we are asking to find the probability of A intersection B. The probability of A intersection B. Probability of A intersection B will be equal to the number of A intersection B over number of sample space. Number of A intersection B we have 1. Number of sample space we have 6. So it will be 1 over 6. Now this will be the solution for part A and this for part B. So this is the way we deal with union and intersection of sets or events with an association to the probability. Thank you for attending today's session. I welcome you in the next sessions. Have a nice moment. Bye.